Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hello, my name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I have my colleagues Hasan Yasar and Jose Morales with me. Dr. Yasar has been recently elevated to being the technical director of a new directorate here at the SEI called Continuous Deployment of Capability. Jose and I both work with him in that directorate, so congratulations and welcome. Today we're here to talk about challenges, which we all are dealing with, in using DevOps in highly regulated environments. So these are environments like nuclear safety, safety-critical systems like airplanes, places like that. And those are some of the areas that the SEI works the most in, so we're going to talk about sort of what are the challenges there in that. Dr. Morales recently, and Hasan also, and another colleague of ours, Aaron Volkman, just published a paper about less than a year ago on this very topic, so we will reference that as we go through things. However, before we start, tell our audience a little bit about how you each ended up here doing this kind of work, because not everybody gets to do DevOps work in highly regulated environments. So why don't we start with you, Jose?
So I've been working, well, first, thank you for having me back. It's a pleasure. I first started working in DevOps with Hasan about 3 years ago. Mm-hmm. And at the time, it was not a very well understood concept. It was still being a lot of effort spent in explaining what it is and the advantages of it. But as it became accepted as an efficient and effective way to develop software, we started getting more and more clients that live within highly regulated environments, which are environments that have heightened security standards because they deal with projects or information that requires this.
Right.
And ever since then, I've been working almost exclusively in these environments, and there's a lot of challenges when you try to do this sort of thing, and that's been going on for about 2.5 years now.
Cool. Hasan?
First of all, thank you. Thanks inviting me. It's a great opportunity to be here. How I started DevOps, it's a long journey for me, and before starting the SEI was 2010, and I was running a company as the kind of doing a software engineering work, being a one person does everything type of situation. You know that startup mentality. We were doing a lot of coding, but not really as efficient. So then I gave up the company to start SEI in 2010. When I started SEI, and I was dealing so many projects, like about 18 projects. Actually, the first time I started using DevOps in managing the projects. It seems like awkward, but it really helped me to manage the projects on time in terms of traceability, tracing, or looking for any project content. So really how it helped me as a team. So team start to really make it visible of their work and to the community, which all the team members, all the stakeholders. So all the work was visible. And if the work is visible, that means I am able to manage properly well what we are doing and where we are in the progress of delivering any tasks. That's how it started. When I see the benefits of project manager perspective, then I saw the developer are taking advantage of being transparent, being sharing, and also getting the collection of information amongst each other, which is basically a definition of DevOps, how it started. So we started implementing since that day now, and we were doing, within SEI, we were doing more about the web application at the moment. Now the DoD centering we do as an SEI, it's more about different systems, and I realized that we cannot take really a web way of doing business or web type of application into the same type of mentality into the safety critical systems or the highly regulated environments. It's not that easy. It's not really you can get the continuous testings like fail and then to recover later on. You cannot let fail in production environment, the safety systems. You cannot let something like aircraft is going to do something crazy things or some other missiles. You cannot let that happen. Exactly. So you have to do some certain characteristic, certain works of DevOps components in that environment. Still with the DevOps, still is applicable, but in a different way of doing the testing, different way of doing automation, and different way of addressing the security. or handling the air gap environments, how we can do that air gap environments, because usually if you talk about the web applications such as Google or Amazon case, and developers are able to go into the production environment, like they can really entitle or empower to the production environment and change the content of applications.
Yeah.
But when you take that approach, you cannot get into the safety critical systems because the developers cannot go to the production environment because of the constraints on the compliances and also the other set of rules is required. So that's...
So what you've just talked about is something that I've heard you talk about is environment parity.
Right.
Achieving environment parity is one of the ways that you allow that transparency and that you get confidence that what you've done all along the way is actually going to work in the production environment. So let's talk about that challenge in particular of how do we approach, I'm not going to say achieve, but how do we approach environment parity in these environments where the regulatory framework or the criticality of the hardware that we're using affects our ability to just say, well, I want to go off and do this in the production environment. Of course I do. How do we deal with that challenge?
So I'm going to start first. Let's describe what the problems are, why we need that environment parity. It's a foundational concept of DevOps. Why the developer would like to see the result in the production environment, because they would like to see anything is failing.
Right.
So what is really failing in application context is the dependencies, an example, or the other environment variables are changing because typically developers are developing a code in their development environment. They cannot replicate the same as production environment. And that's the reason they would like to see production environment, take a look at the results and how the system is behaving over there. Then if we get a parity, it means like the same configuration of environment, so we can give the chance to developer not only for using their dev environments, they can use in their staging environments as the same environment as the characteristics of the production environment. It doesn't mean that we have an identical in terms of CPU and memory and usage. We would like to have the same configuration, same dependencies through that environments.
Jose, did you want to add something to that?
So I've been thinking about this, and I divide environment parity into two areas. There's environment parity amongst developers with their development environments.
Okay.
And then there's environment parity between the staging environment where developers test their code and the actual production environment where it will eventually live. I've seen problems in both areas.
Right.
When it comes to the developers, if they do not have environment parity, then simple things like a dependency that changes, a library that's different, a subversion of something, will build two pieces of code that are totally different. Right. And thus, this person says it's good, and this person says it's bad, and I have to go back, figure out that's extra time, extra cost that's not required.
Right.
Also, if they're not storing or sharing their code correctly, and there's this difference, the one that didn't build right or built with a different version of what's expected could end up being deployed out.
Sure.
And then therefore you have a missed configuration. Right. And I've seen that cause several issues.
And those are really hard to troubleshoot.
Those are very hard because it's this minute little detail buried away in a subsystem library.
Yep.
The other issue is when you have your staging environment, which is your internal production environment. It's controlled by the developers. It should always be as equivalent to the production environment as possible. Now, in some cases, the production environment's a huge system of which you are developing one subsystem. So at a minimum, you want to have a staging that has parity with that subsystem, the immediate environment under which you will be running once you're deployed out. Emulating or testing the connections between that subsystem and other parts of the greater system is a bigger challenge. Sometimes it's unachievable, sometimes it is. When it's not, you're taking a big risk because you are going to test for maybe even the first time your communication with other parts of the system when you're out in production. One of the key things that have been adopted today to avoid these sorts of issues and sort of enforce environment parity is the use of containers, Before then was the use of virtualized environments.
Right.
So well-equipped developer teams have a provisioning server. This server will build you the environment you request. So everyone agrees upon an environment for development, and this provisioning server gives you a container with the environment you're going to work on. So everyone's working on the same thing, all the developers. Staging in highly regulated environments can be very difficult because the production environment is either inaccessible or it's just not accessible now.
Mm-hmm.
Sometimes a thrust that has occurred in the community is for some systems upon which you're building for, the manufacturer of that hardware will make available sort of an engineering release of it.
Yeah.
In some cases, the developers, the customers, all the stakeholders, which true DevOps involves all the stakeholders, will come to agreement that this engineering release, which is publicly available, is good enough for a staging environment.
Or give caveats as to where it can't be.
Correct. You'll identify where the gaps are.
Yeah.
You'll measure the risk of testing in that environment with those gaps. In most cases, they're acceptable, and everyone will test as a staging the engineering release because it's the closest you're going to get to the production environment.
So this brings up a different challenge, which is a life cycle challenge, which is if I, as a developer, am trying to get this environment parity in a hardware subsystem, we'll just say some kind of a hardware subsystem, I have to coordinate with my systems engineering community and my program management community to make sure that those engineering releases are available, of that hardware are available in a time frame that I actually can use them. Because one of the things I've seen is where if that's out of sync, if the hardware people don't know that the software people need an engineering release to work from, then they're moving along and they're not planning to deliver anything for another 6-8 months past when I need to test things. So that's one of the challenges that I've seen in moving into that hardware-centric kind of software environment.
And I like to add to that one observation I've made out in the field in these environments is when you're applying DevOps, a key aspect of it is testing in small chunks your code. You do unit testing, you do functional testing, you do integration testing. But in most environments that I've been in, the testing does not include an iterative process where you have staging involved in it. And in some cases, if there's a big gap between staging and production should be involved in it as well.
Right.
Usually, the testing is unit testing, little chunk, unit test, great. Functional test requirements are met, we're done. Then we integrate into the larger stream of code with everyone else that's working on this project. At that point, you are now testing in likely a virtualized environment with everybody else's code, but it's not truly staging.
Yeah.
So the staging's lacking. In cases where staging is there, it's a one-shot deal into staging. It's not necessarily iterative, because the assumption is once you have met the requirements, you don't have to keep doing an iterative testing process. Which is completely not the case.
Yeah, and actually one of the things that drives that is the cost, right? The cost of system integration labs, of hardware that I can use as a prototype. Often that's a scheduled resource, right? It's not something where I can just say, hey, I'm ready, and if it fails, I can go back and tomorrow I can get in again. There's a queue of people waiting for that scarce equipment because it's expensive in many cases. I mean, you don't have nuclear power plant stuff just sitting around, waiting for you to do iterative testing on it.
That's right. You cannot really replicate exactly the production environment.
Yeah.
Let's go back a little bit environment parity again, as Jose described. We are really looking for a similar characteristics. That characteristic means sometimes you should have a maybe hardware prototype and maybe having a simulated environment.
Right.
Like thinking about if I'm going to run this A system in a bigger picture in a production and what my system's environment is, try to build up environment from production, try to carry to the left. So we call it like a shift left.
Yeah.
we don't want to get the shift left only for the security component. We would like to get the shift left onto the production parities as well. Build it, getting hardware engineers or system engineers and describe what are the elements of the configuration of this environment, or what are the characteristics of the environment are, and try to simulate that environment first. And then simulation is going back to your point, you said the cost related, because cost is too much in the hardware. You have to spend a lot of time and money. Why don't we try to think about a simulated environment first as for testing purposes? And I know most of the hardware engineers, they're using a simulated environment first before building the hardware.
Sure.
So if I know my systems, embedded systems, I'm writing a code, then why don't you use my code in that simulated environment to see how it behaves? Forget other components yet.
Right.
If I'm building a skeleton of the house, I would like to see the boundaries first. Make sure that it's going to work, that's going to communicate well, then I can go deep dive in each iteration. So starting from in connection with the hardware and software engineers, look what we can do as in terms of small testing cases. And where is an environment that we can build it together, which is a simulation environment can be done.
And this kind of relates to the DoD's
Yes.
digital engineering strategy,
Right.
is trying to look at improving our overall modeling and simulation capability.
Right.
And this is one of the areas that it can really pay off.
Right.
Is if we start looking at how do I simulate the pieces and not just the pieces, but the interfaces in particular that I need to be able to do iterative testing and get that environment parity.
Mm-hmm.
All right, so we've beat environment parity to death. So what are some of the other challenges that you run into when you're in these highly regulated environments that you want our viewers to pay attention to?
And I would like to bring the disconnected environments, because you cannot really connect the dots through the system-wise. It's the disconnected. It is a total different networks, which is actual production environment running over there, which is maybe classified. And when we're talking about maybe totally disconnected, means like developer cannot push the code in one button that goes to the certain steps and build and deployment, suddenly production environment.
Yeah, there's still sneakernet involved.
There is some sort of communication mechanism, either sneakernet or somebody has to do some extra work as a human and move the code from one environment to another environment. It's a big challenge, actually.
I've seen this happen.
Yeah.
Where people sneakernet information from open environments to closed environments, and there's all sorts of problems in the closed environments. They need updates multiple times a day. In the open environment, where they're going to upload by walking from one place to another, occurs once a day. So that pushes back schedule unbelievably, because there's no automation involved. The key part of DevOps is automation.
Right.
You could have for example, to get really technical, a diode that just shoots things one way, and it automates to upload information on a more regular basis. But then you get into the business model of things. Is it worth it to do that? Should we do that? There's a big gap in automating movement between open and closed spaces, and for obvious reasons. But from open to close should be an easy implementation that can be automated outside of the required authentications. And with some proper encryption, it should work fine. It's not done, and as Hasan was pointing out, it does cause several problems, especially setbacks.
And this is the kind of thing where we have a cultural component too. The culture of open to closed is often manual is better because humans are involved and can check.
Right.
What we're saying is there are places where the human actually introduces risk by not allowing us to have the updates as frequently, by not allowing us to have the system available in areas where it's needed. So we've got to get some cultural kinds of mindsets. We're not trying to say go closed to open. Nobody's saying that. But this one direction, we should have a little bit easier time.
Just going up a little bit more, it's not just the human over there. There is a physically disconnected environment also. Like totally disconnected means like there's no way I can connect my current network into that environment. There's no way. Like you cannot really have the build process on it. So now you have to have human elements in the process, get the system built, put into the other side of the environments or the places. So there's a couple of things we looked at the solutions as an advice what we can do. And that goes back to the environment parity. I have been seeing that the organizations are successful. They are keeping environment parity on the both sides. So if I'm building an application as a container, that I'm sending that container either through the SynchronNet or somebody will carry with the CD or somehow that goes into the that different environments. But make sure that we are eliminating any manual process, like such as build process. So take care of the manual process on different environments, and like in dev environment, staging environment. Build a package, can be a container as an example, can be another binary files, has been analyzed and approved, and it's good to go. Since we know the environment parity is the same for the both environments, so my code will run exactly on the other side of the house in the high side.
Right.
We call this in high side. In the other context, maybe totally disconnected nuclear physical systems, probably safety systems. So get code pieces has been packaged properly, and we know the dependencies. Since environment is the similar configuration, same parities, then we can write the code in the high side environment.
And so what we're looking for is I call it 1+ button pushing,
Correct.
right? It's I've got this package that has been established, and I really should only have to push one button on the other side to kick off the whole provisioning activity that will result in the same system in both places. There's the plus in there if I've got to get it to the place, but we still are not looking for completely manual builds. That's
so it's going to be automated. So we're going to automate the build process. We have to build artifacts automatically. We have to create all the requirements that the application will run automatically in the environment that we are working on it, and just push the new build is ready to go.
Right.
Another maybe audience can ask the question why we are not building in the high side or that environment. There are some limitations on this environment. It's just closed environment means you may not be able to reach out the internet. You cannot really pull a new set of libraries. Because in this day and age, we talked in the previous podcast, we all depend on the internet right now, be honest. Like all the engineers are looking for new libraries and understanding how to write the code and stuff. It is very difficult or time consuming building an application in a constraints that you cannot go, you cannot look at the nodes, you cannot try anything else. So you need some flexibilities. So if you look at the DevOps things, is so much getting very attention in the community because it's giving so much flexibilities, and developers can go and pull up a ready container or ready configuration like a chef recipes or cookbooks somewhere else from internet is available. We don't need to rewrite that configuration element. We don't need to rewrite some images so we can use that. We can use ready provisioning scripts. We can use ready configurations or deployments. It's available. We just have to go change some of the components. So this is not available in the closed environment. That's the reason we have to build something in different environments and push to the build into the high side environment. That's the difficulties actually.
So you and I, actually I think I'm older than both of you, but I grew up in the days when, no internet, let's just start there. And so handcrafting code was the only way code was built. The number of libraries that were available for different common functions was still kind of limited. And so I'm just thinking that people that actually grew up in that environment actually have an advantage in some of these places if they're actually accustomed to handcrafting, where some of the people that have grown up in more of the internet space are not as accustomed to this sort of handcrafting idea. That's just something that sort of came up as we were talking about it. So advantage to being old for once. Yay! All right, so let's talk a little bit about compliance. So one of the things about regulated environments is there are typically compliance issues. Someone has got to prove to someone else that you've complied with safety regulations, security regulations, financial regulations, whatever they are. And what are some of the challenges and solutions that DevOps offers to help that side of the highly regulated environment?
So I'm going to talk about the challenges and hand over to the Jose for the solutions.
Oh, thanks.
Or vice versa, we can do.
That's fine. Go ahead.
All right.
That's fine.
So what are the challenges that we saw that in the compliance perspective? Usually, mainly is the responsibilities, because we are building a system that has to comply some privacy. Or if I'm the financial sectors, I have to be compliant with the SOX and HIPAA is the health industries. So all this, the compliances have some certain controllers has to be in it. The controllers depends on which compliances we are working on it. It is requiring an approval process. It is requiring some audit traceabilities, such as if you look at the GDPR as an example, which is more about the Privacy Act. As the developer or system builder, we have to show evidence of how we are handling privacy in our application life cycles. And same thing for the financial sectors. And there's some certain things has to be in place, and auditors will look at the code pieces or system to verify. So human, an auditor or assessor has to approve the process. The challenges are it's all manual process, because these people are looking for artifacts. These people are looking for artifacts such as for how it is done, how it is implemented. And going back to the context is about the ATO process. What are the controllers are in place? And as an assessor, information assurance person, I need to know how it is implemented, which phases has been done proper testing and evidence. So if it is manual process, is manual, somebody has to say, yes, I did it. Here's my checklist and checklist and checklist for every component. It takes time. It's a big barrier because we cannot really push a version, the application to the production without getting this approval. Right. It takes 6 months sometimes. Now it's a big challenge. So how DevOps is really helping?
How can DevOps help me with that, Jose?
Right. Well, I've seen this in action out in the field and using DevOps. And what I've learned is you can build the compliance into the DevOps process when you're building in little nuggets of your work. There's this one place I work at where they call them nuggets, but I think it's a generic term. You build a small piece of code, it goes through the regular testing, but within there's this one chunk called quality control, quality assurance, compliance control. Once it goes through there, as part of the DevOps process, it goes in and they check that little piece of code that you gave, if it's meeting all the compliances. Now, within that, there might be some automated testing to which the compliance officer is shown the results. There's still some manual parts because there's paperwork and other things, but you can build the automated parts in a DevOps way. The manual part you compile. And once you've hit a certain amount that's acceptable to give all of the needed documentation, you give that in with the automated results that you had from before. So it actually does accelerate the process. And one major issue that we have is not compliance, but it's ATO. I think you're going to cover
authority
this.
To operate for
authority to operate. I think you might cover this later on. This is a good topic for its own podcast. That's been built in as well because you can automate a lot of the requirements for hardening, for sticking things, all the compliance needed to show that this is authorized to go out into the production environment and operate there.
Yeah. So I'm going to open up a little bit the solution side of it. So when you look at all this compliance, as I said at the beginning, there are certain things is required, such as report, audit, and traceabilities. So what the real DevOps is bringing, that's kind of my journey, how it started from SEI. I was able to see every report, every project, it was completely traceable for me. So DevOps really brought me a traceability of any given projects. And I'm putting myself in a situation, if I'm going to approve a process, the systems, I need to see all the issues has been created, and I would like to see all the test cases has been done, and I would like to see test reports. So DevOps is bringing that all elements automatically, and in the DevOps pipeline, it's all connected. My issue tracking system is connected to my repository management. Right. Then my build server is connected to my repos and an issue tracking system as well. Then all my testing is also connected as a part of continuous integration server. So if system is automatically creating any result to me as a report, how it is done, how it is implemented, either doing proper testings, then I'm getting the reports. And I know exactly, as I'm looking for an auditorial perspective, and I can see who touched the code, when they touch the code and why they change it.
Right.
It's one of the requirements in the financial systems. You have to prove why you changed that code and for what reason. There is a traceability that goes back to the requirement, which is another and VNV verification and validation process requiring to show how it is valid, how it is verified and validated. So these are the components DevOps out of box is generating if you implement properly. That's one of the things I think we discuss in other podcasts. DevOps is not just CI server; it is the whole life cycle.
Right. We
have to have the systems how we are building from the beginning, which usually the planning phases in it, and how you do the case management, how you do the wiki page. That all way goes back to your production environment. This is the life cycle we are talking. This is DevOps pipeline we are talking about. If it is properly established, and auditors can collect every information easily from every life cycle.
So one of the things that I've seen you demonstrate in some of the classes that we teach is this idea of embedding documentation that would not normally be considered code documentation, and I'm thinking about compliance type of documentation, using markdown languages and things like that, so that these reports you're talking about, what I've seen you do is to actually generate them from the code base.
Absolutely.
And so the term that you've used for that is infrastructure as code, which I love because it gets you to the planning. The infrastructure is that whole life cycle infrastructure, not just my configuration management. And that concept is one of the things that I think is one of the ways for the regulatory environment, for the people working on that side, to start thinking about suggesting things. Why can't we have these kinds of compliances included in the code base? And that's, I think that's a really powerful solution for moving some of the folks that are really overburdened. I mean, most of these authorities, whether it's financial or HIPAA or anything else, they are overburdened with these manual processes, and they don't really know what we can do for them. So this is part of the education.
The community is building a lot of compliance as a code concept. It is available in the GitHub. There's a lot of folks are feeling the same pain, then they're building up a library. It's like libraries are a set of code automatically checking the configuration. If I am doing something at the OS level, and there's a FISMA compliance, it goes check automatically that my system is compliant or not. It is automatically done. So even though the configuration elements or the configuration tools has a built-in capabilities looking for the configuration of the systems in that level. So it's really available. The communities keep producing that. It's another things like the developer will like to be part of connected the community because it's available and use that piece of code. Will check how we are doing in terms of compliances, like who's accessing the environment, one example that they require from the financials, or how I'm handling the PII data in my systems. That's a possibility.
So so we've hit environment parity, and we've hit compliance, and we've hit full life cycle involvement of stakeholders, and we've hit dependencies and interfaces as being big challenges. Is that enough for our viewers for one day, or do we have other things that we want to bring in before we
can add many more. I think one interesting one that I think we could talk about is authorization to carry out a project when the request comes in from a customer. Oftentimes, this is a part of the SDLC that's not necessarily well defined because it's viewed to be outside of it. And in a way it is, but it impacts. So I've seen scenarios where a customer puts in a request to build something. The developers receive it. They have to send it off to management to have them sign off.
Gotcha.
In the environments that we work in, management is not the person in the office next door or down the hall in another building, in another city, in another state. When you pass that on to them, the amount of time it takes them to sign off can be highly variable.
Sure.
Now, for long-term projects, this is no problem. I'm talking projects that are months or years. But there's projects where you have weeks or days, in some cases hours.
Right.
And you still have to get this authorization. The time it takes to acquire that, which you cannot start until it's in place, digs into your development time And the amount of time allotted to something like this is never takes into consideration the time to get it authorized. So one thing that we came up with is to do a fast authorization where there's someone on site with you, with the developers, who can authorize it while it goes off in its usual process.
Right.
The reason why it authorizes on site is because of the short time period. Now, this isn't DevOps directly, but when you're in highly regulated environments and you're building a DevOps process for their SDLC, you're not going to answer everything with DevOps purely.
Sure. Of course
There
not.
are issues in there, and I've dealt with them on the ground, is the solution is a non-DevOps solution, but it augments the DevOps and it enables DevOps to move forward.
But I'd argue that even then, if you look at the DevOps principle of collaborate, I mean, it's right there, right?
Right.
This is we're
sure.
finding a way to collaborate,
Correct.
even if it doesn't involve automation.
This is
and
true.
So I would say, I'd say it counts.
Why not? It's a good point.
The purple-haired woman said it counts, so it's got to be right.
Absolutely.
Which is a collaboration piece has to be in place.
Yeah.
That's a big thing.
Yeah.
So I looked at the number of the problems or the obstacles we discovered. It was about 12, so we can cover up the rest of the stuff in other time. It's
Maybe-
a lot.
Maybe we'll
Yeah.
give
We
people
cover-
a break and do some.
Yeah, I think
some
we
more
cover
next
up the
time.
fundamental concepts and start from the ground up and talking about environment and talking about the approval process and talking about the compliances. These are the hardcore issues in our solution we discuss. I think we can go deep level.
We can have another time.
And
when-
talk about acquisition is one of the things we have to tackle
Yeah.
it. We have to talk about the people, which is the skills is
Mm-hmm.
required, and then also the changing of the people roles or the people moving from one another location, which is retentions.
Yeah.
These are things we discover, so probably can talk about next podcast.
Okay. And the paper that Hasan is referring to is called Implementing DevOps Practices in Highly Regulated Environments. The link to that will be in the podcast transcript, so people will be able to find it, and then they can read about those so they can get ready for our next podcast
Great.
on this topic. I want to thank you both for joining me today and having this conversation. You know that I'm passionate about sort of bringing these things out into the larger world, so I really appreciate you doing this. And for our viewers, as always, if you have any questions, please send them to info@sei.cmu.edu. Also, don't forget, you can find this on our YouTube channel. You can find it on SoundCloud. You can find it pretty much anywhere that you get your podcast today. So thank you for joining us, and go forth and collaborate and have environment parity.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.